So if I'm talking about an exponential function, that is anything where the variable is in the exponent. So it's not like x squared or x cubed, it's 2 to the x power or 3 to the x power. We need a little bit of terminology as we're going through that, just so you know what I'm talking about. So we know the exponent is the power. The number being taken to a power is called the base. So an exponential function is of the form f of x equals a to the x. A is just a positive number other than 1, and it's called the base. I'd like to talk about the graphs of exponential functions today. When we're graphing those, we really need just a few points to get a good idea of what our graph looks like. So we're going to look at a couple different ones and see if we can kind of notice something about these graphs. Does everybody have what they need from this slide? So I want to graph f of x equals 2 to the x, and then we'll do 1/2 to the x. So anytime we're graphing something new, we make a t-chart. All right, when we are graphing, we plug in some numbers for x. So maybe a 0, 1, 2, but is it a good idea to only do positive numbers? No, so let's try some negatives as well. If I put in a 0, what is 2 to the 0 power? 1. Anything to the 0 power is 1. If I put in a 1, what's 2 to the first? If I put in a 2, what's 2 squared? If I put in a negative 1, what does a negative exponent do? Puts it on the bottom, so it makes it 1 over 2 to the first, so 1/2. If I put in a negative 2, that makes it 1 over 2 squared, so 1 over 4. All right, do we have a pretty good idea of what this looks like? We can see this is rising, it's curving. Will you ever do 2 to a power and get 0 for your answer? No. I mean, if you're doing negatives, it'll be like 1 over 8, 1 over 16, 1 over 64, but will it ever be 0? No, it's getting closer to 0, so what do we call that? It's an asymptote. So it's getting closer to the x-axis, but not actually hitting it. So that's what 2 to the x looks like. Let's compare it to 1/2 to the x. So if I wanted to put in the same points, what's 1/2 to the 0 power? 1/2 to the first. 1/2 squared. What happens if we do 1/2 to the negative 1? And 1/2 to the negative 2? So we get a very similar type graph. All right, I want to answer a few questions about each of these. So I want domain, range, increasing, decreasing, and asymptotes, so we can see what's the same and what's different. We had our 2 to the x and our 1/2 to the x. What's the domain of my black one up here, the 2 to the x? What's the domain of the red one? What's the range of the black one? And we don't hit 0, so it gets a parenthesis. What about the other one? Okay, so domain and range were the same. Increasing and decreasing. What's the black one doing? Increasing the entire time. What's the red one doing? Decreasing. Why do you think they're different? What's the difference between 2 to the x and 1/2 to the x? The base. When the base is bigger than 1, the graph is rising. When the base is smaller than 1, the graph was falling. What kind of asymptotes do both of these have? Horizontal, y equals 0. So they have the same asymptote. So the only difference we are seeing is whether it's increasing or decreasing, which is decided by its base. So really, in general, I usually ask you to pick how many points? 3. If you do 0, 1, and -1, would that be enough to know if your graph was rising or falling? Yeah. So if you can at least plug in those 3 points, then we can get our graph from there. Okay. And I know the bell's going to ring for bus riders in just a minute, so I'm probably going to stop there today. I just really want to get the definition and kind of the basics of the graphs. Tomorrow we'll look a little more at those graphs. Okay.